Profile milling has traditionally involved plunging to a depth, leading into a profile, machining the profile, then leading out, and repeating this sequence of moves until reaching the final depth. If the profile happens to be a pocket, then pre-drilling a start hole for the milling tool may be an additional step. Dapra has a more efficient approach, high feed ramping. By starting directly on the part profile just above the workpiece and executing a constant ramp in the Z-axis, the part profile can be roughed in much less time, eliminating time-wasting entry and exit moves and achieving metal removal rates that rival high-efficiency milling, but without the cost of the solid carbide end mills. Our first example is helixing a hole. Rather than drilling and circular interpolating the hole, we begin directly on the hole diameter with a helix motion, similar to thread milling. We execute the helix at a constant pitch until reaching the bottom, at which point we execute one flat, non-helical pass to create the floor of our hole. The spindle load never exceeds 15% on this cut. Next, we demonstrate a closed slot. Notice that in this case, it's a radial slot, meaning there are no straight sides. Now normally, a start hole would be drilled in one end of the slot and used for plunging into with the milling tool. With the high feed ramping approach, we'll begin executing the slot profile just above the part, repeating the profile with a constant Z-axis ramp. Now this is simply programmed using the ramp option in our CAM profile milling routine. We tell the CAM software to execute a flat pass to create our pocket floor once we reach final depth. At times, the pocket or slot may be larger than 2 times the cutting tool in use. In these cases, we offset the final profile of the CAM software to create an internal pocket to rough initially. In this lightening pocket, we first machine the internal offset pocket, then move to the outer profile to complete roughing of the pocket. Chip removal is a bit easier in this case, since the cutting tool is so much smaller than the pocket being machined, leaving plenty of room for chips to evacuate. For the fastest cycle time, however, use a milling tool that is at least 50% of the narrowest width of the pocket, so that milling of the profile automatically removes all of the inside material. Outside profiling is also handled well with high feed ramping. Again, we start right on the profile just above the part. In this case, we use a shell mill due to the deep cut in the front portion of the workpiece. Now this area would require many radial passes when using high efficiency milling techniques, but with high feed ramping, we take it all in one width pass. Now that you've seen the approach, imagine this workpiece at 3 times the depth. Using the high feed ramping approach, the only change that would be made would be to use a longer effective end mill or shell mill holder. All speeds, feeds, and depths of cut would remain the same. Now this cannot be done through high efficiency milling. High feed ramping provides a faster, longer reach, more cost-effective approach for your roughing applications.